Hey, wait, cinema? Oh, for the starting soon screen? Ooh, congrats on the first. There we go. But yeah, I saw you asked Zach about the stuff that you've been working on, Lucas, and I think that was a good idea. I'm glad you did that because I feel like he could probably think about it better than I could. But yeah, I think until we get a question, I'm gonna be reading about Fourier, like the smartest math person I know. Ooh, that's a good question. Like he probably is up there for me. No. I know nothing about math. I would absolutely like rank Zach way above me. I'm checking. There's one person who I knew when I was doing my degree who's really smart, and I'm still really impressed by. So he's coming to mine too. But then also like on Twitch, there's like say like Stooky, Mega. Not necessarily just like streamers, but also like if we get into chatters too, then there's a lot of competition. Klonk, thank you so much. I hope you have a good day. Very difficult math problem that was in my textbook. Yeah, sure. Um, yeah, sock now. These are integrals in a very weird context, but uh, I'm trying to learn about the Fourier transform, which I've learned before, but not from this perspective. And Fourier transforms are defined with an integral. This is a lot in like electrical engineering, especially, or anything that involves waves. Fourier transforms come up a lot. Sage, hello. Hope you're doing well. Oh yeah, Zach, this is where that came from. I was trying to read the Fourier section in Laplace. I haven't gotten very far yet, but I want to spend some time with the stuff that they have already talked about. And so what was really making me uncomfortable was the book just dropped this notation here without saying what it means, and that was making me really uncomfortable. So I was glad to hear you say this is the L2 norm of F. I want to say, like, just like how to pronounce it. I guess this is the definition over here. Apply for a guest service representative job over the next city. Hope you get it. Oh, nice, Sage. Well, good luck with that. Hope you get it. Yeah, and so I assume we don't care about the actual value of this normally. We just care that it's finite. I want to try actually applying this integral to an example function. Just to, like, say I've done it. Oh yeah, and so there's this thing where, wait, 4.5.1. The Fourier transform converges to the mean. This thing does not necessarily converge. So that, like, this doesn't have to be a continuous function is the weird bit. We don't generally care. Okay. Integrals with infinities, yeah, they're called improper integrals. So a picture of it. For the hardest question my math textbook this year, might have already tried it. Yeah, we can see it. So it's awkward for Fourier too. The definition of a function. But yeah, so this is like one of the properties that the book just kind of asserts is true. And the book goes to great lengths to not talk too deeply about this LP stuff. But they still bring it in, and so it's kind of awkward. Proofs are in functional analysis. Oh my, it's functional analysis? Okay. Then that's probably going to be above my pay grade. Now as a master's degree, yeah. Yeah, no, when I told a professor, so or like, what am I trying to say? One of my old professors from when I was doing my degree, is the one who like encouraged me to even apply to grad school in the first place. I applied to her old school where she got her PhD actually, and UW. I got accepted to both for a master's, and she said that going to UW is a no-brainer, despite me getting accepted to the school where she actually went. Oh wait, yeah, I think maybe we did do this. We can think about it again. This sounds very familiar though. Okay, so classic Pac-Man problem. This is not even close to a circle. Isn't there a story where like when Michelangelo or whoever was like applying to be the person to paint the Sistine Chapel, he just drew a perfect circle on a piece of paper and that was his application? I think it's a story. There we go. It's close enough. And so alpha is right here, the mouth of the Pac-Man. Don't know how I'm supposed to solve this when the age is 16, average people attempting this. I mean, do you have calculus for this? Oh, the Instagram one or the dual number one? Okay, so yeah, calculus is allowed for this. So how does this look as a cone? R and so I remember that there's some oh, the Instagram one. Yeah, so that was the one where someone claimed to solve the Riemann hypothesis. I have never attempted a JE paper. I would not find that fun, to be honest, Najaf. I really dislike JEE questions. The radius or the circumference of this partial circle is something. Well, we also know that the area of this circle is the same as the surface area of the cylinder minus the bottom circle. But I feel like we can do something with circumference. I'm trying to remember what that thing is. G's. Okay, yeah, the circumference of this partial circle is the same as the circumference of this base, I think. So that is equal to 2 pi r something. Two pi r times alpha if alpha's in radians. Sorry, 2 pi minus alpha. First picture is just a view from above. Yeah, I mean, I think that's where I'm getting this circle thing. Just trying to bring in the alpha. Is what I'm trying to figure out. I think I've done it. I'm trying to make sure this makes sense. If alpha equals 0, well, that's not quite right. Is alpha divided by 2 pi? Or... is it 2 pi minus alpha over 2 pi? I think it's that. Now this should check out. So I'm checking with alpha equals 0. We should get the entire circle back out. Okay. So we can simplify this. 2 pi r minus alpha r? It's been gone for longer than 5 minutes. It's serious. Okay, so we can use... this is the circumference of this circle here is the point. And so we can use that to find, maybe we need R1, R2. So that means 2 pi R2 is equal to 2 pi R1 minus alpha R1. Slim, thank you so much for the raid. I hope your reading group went well. Working on this question up here from Lucas. I think we've solved it before, to be honest, but we're doing it again. Hey, Rex. Why? Because of the overhead view thing that you were saying. So, like, the circumference of this partial circle is the same as the circumference of this base circle here. And so I made the radius of this base circle just R2 just to give it a name. And we know that 2 pi R2, like using the circumference using this formula with R2 should be the same as circumference over here. What's the volume of a cone again? It's a third pi r squared h. Let me fact check. Yep, okay. Minus, that comes from this bit over here. So the circumference of the partial circle, the total circumference is 2 pi r1. But we only want part of that. And so I'm thinking of this factor here as acting like a percent. Where if alpha equals pi, for example, we will just have like a semicircle down there, and we will just want half the circle. Or like half the circumference. What, where am I going with this? And so that's like one way we can check this formula here. If we plug in pi for alpha, we do get pi over 2 pi is 1/2. And so this is a way of basically just taking a percent of the total circumference. And so if alpha equals 0, we'd have the entire circle. So we just get 2 pi over 2 pi is 1. And so and that's like good. Just of everything into V. So that's only in terms of R1. Yeah, I think that's what we're going to do, Joseph. Yeah, the percentage thing is based on alpha because man, this is I don't know why I have such a hard time explaining this. I tend to just have a feeling when it comes to percents, and I have a hard time explaining them. Okay, yeah, so alpha basically determines what percent of the circle we want. So if alpha is, say, a right angle, then we want 75% or 3/4. If alpha is 180, we'd want 50% or 1/2. I'm just taking some easy examples for like numbers here. Or 270, we'd want just 1/4. But I want to do things in radians. Okay. So if you know that alpha over 2 pi is the percentage of the circle, the only thing we have to do is remember that we need, in our case, we're measuring the interior angle here as alpha, so we need to do 1 minus that. We need to like invert the percentage because alpha over 2 pi is the percentage of the circle if you measure it like this. But in the problem, we're measuring it the opposite way. Both are correct. You just need to be consistent for whichever one you choose. And so, yeah, so that's why we need to like, if you want to kind of invert a percentage, you do 1 minus that percent. I think so. I'm not sure what you mean by middle point, but we're measuring like the part that's not in the circle, whereas the thing that you said measures it from the inside. I mean, if you're in the middle of the circle, I think you could look at either place, I guess. So that's why I'm not understanding it. But if it makes sense in your head, then go with that. And so this thing right here is the same as what I wrote here, because we could get a common denominator. So this and that are the same thing. So like we're both right. It's just two different ways of thinking about the same thing. It's yeah. Honestly, Lucas, like I think the easiest way to tell the difference is to plug in easy numbers. So if you initially guessed alpha over 2 pi, just try plugging in like this case right here. If alpha equals 90 degrees is pi over 2, then we would end up with pi over 2 over 2 pi, which is 1/4. But we expect 3/4 here. And so that's what would tip you off to do the 1 minus that instead. So honestly, I just verify it with examples. That's the easiest way to do it, I think. Hey, Storm, this is the problem up at the top here. Hey, Viramala. And so I think we have everything we need to actually solve this problem. So like basically the approach to the problem, I should have written this part first. The volume of the cone is 1/3 pi r2 squared h, but r2 isn't like related to the problem as it's stated. So we want to get rid of r2. You know what? H relies on r2 also. I think I'd rather just work on some math right now. Wait, we probably need to worry about H, don't we? Pythagorean theorem. You were joking? Okay. Okay, so we actually have a hidden right triangle here with R1 and R2 inside the cylinder. So if we want h, we can actually Pythagorean theorem our way around that. R1 is the hypotenuse. It's equal to R2 squared plus h squared. So we want h, so let's solve for h. A little bit, Virmala. Storm, we're creating the cone by joining these two sides of the cutout. Okay, so now we want to get rid of R2, we want to get rid of H. First, let's get rid of H. I need more room. H is root R1 squared minus R2 squared. Yeah, Virmal, I'm gonna be a little bit like busy because I'm about to move and I'm gonna be starting grad school soon, so I'm probably not gonna have time to tutor new people right now. What I've learned is there is redundant ways to mathematically explain the same thing. They're not necessarily, they don't have to be redundant, but there's definitely different ways of looking at the same idea. Yeah. Yeah, sure, Joseph. Okay, so now let's get rid of R2. First off, let's take this equality and divide out 2 pi. This is going to be a little annoying. It's the inside of the angle because it's the angle of the sector that's being cut out, Storm. Virmala, I'm sure that exists. I know nothing about that, and I definitely could not tutor in that anyway. No worries, Slim. Thank you again for the raid. Yeah, we definitely have done this one before. This part is going to be... I wonder if I found an easier way last time, because this is going to be a little annoying. I feel like the music's a little bit loud. I'm going to turn it down just a teensy. Oh, on the cone. I mean, alpha determines the circumference of the base. Like, it's right there as the circumference here. Do we get a simpler relation if we think about the area? Because the next step is going to be to take the derivative of this in R1. And that sounds a little bit terrible. Like, we can simplify a little bit first. But I just want to explore what happens with the area. So the area of the circle. Then what's the surface area of a cone? The surface area of a cone without the base circle is pi r. Okay, no, I don't think that's going to be any simpler. All right, we'll just plow through this. So I'm going to multiply that square out. The r1 squared will cancel with the r1 squared. Hey, $7. I don't want to take this derivative. You lost your streak? It's not the first robbery that's happened. You blame Daisy? The height of the cone, I use Pythagorean theorem. I named the radius of the base of the cone as R2. Yep. That's what I did. So that's like this is what I found here. And so I plugged I plugged in the height of the cone using Pythagorean theorem, and then I got rid of R2 using that relation there. It's just that the next one we take the derivative of this in alpha, and that's oh wait, in alpha, not in R1. That's still kind of terrible. Alpha is easier to do than R1, I think. I don't know, it's kind of a wash. That's also what you guys are doing the number theory stuff. If I had more brain power, I would have loved to follow along with it. Okay, can we just product rule our way around? Oh, you're just dropping this problem in leaving? Fair enough. I'll see you around, Lucas. Oh, sorry if I lost you. Uh, it's basically plugging in all the relations we found into the volume of a cone. Um, oh, the partial derivatives. I mean, that's just a notation thing. Like, I could have also written this. Just take the derivative with respect to alpha. I was just saying that like R1 is another like. You could think of it as a variable. For the sake of the problem, I guess it's fixed. Then product rule. It's not close? Okay, well then I'm not doing this way because it's painful. I think this will, as long as I didn't make a dumb mistake, I think it gets the right answer. You hate shapes and therefore this question. Okay. I'm gonna say that the radius is now A. I mean, Zach also just like gets busy with other stuff, so he might have just like gone to hang out with his kids or something too. I got it from equating the circumference of the base to the circumference of the partial circle. This doesn't feel like it makes sense. I probably made a small mistake somewhere. The answer allegedly would be 4 pi over r. That doesn't make sense to me though. All right, see you, Lucas. Uh, Joseph, you can just post it in the math discussion channel. Oh, maybe I really messed something up. So I'm not getting an actual number. Didn't I already looked at a problem that was just like this from the same person? Yeah, this is a Hilbert matrix, or this is the inverse of a Hilbert matrix. No, it is a Hilbert. No, it nearly is. I can't do this. For the invertible part, you could maybe do induction. The integer entry part, I have no idea. You have to do something with the joint matrices, probably. Honey bunches of votes? Nice. My guess is that you're just hanging out with your kids or something. Yeah, this one, no clue. Joseph just posted a math discussion. This window never finds it. There we go. Just posted in math discussion. Yeah, I told him you're probably just busy. Then while we wait to see Joseph's question, I'm just gonna go back to this. But you know what? I'm changing the music. I'm not feeling this either. Yeah, Storm. This complex variables book I've been reading. I've just started to read the Fourier transform section. They're talking about LP spaces with it too, and I've never learned those before, and they're really giving the short story. Like they're just like skipping over a bunch of stuff for a good reason, because it's really hard, but it's not making for an easy read. Oh yeah, in this book, we skipped over some of the optional sections, but as like a group, we got all the way through 4.4. I need to go back and read some of the sections that we skipped, but... Oh, never storm. That's what makes this section really difficult to read. And so, this relation here, I had to think a lot about. They just say it follows directly. It's not very direct for me. But we have to think about this. Or one of those. Yeah, the famous it's quote unquote obvious. Oh, you posted it. For LPRP is finding a problem P equals infinity to understand what it means. Okay. Yeah, I was asking Zach about it. Um, and he mentioned that like L infinity exists, and I was like, what? Weak derivatives? I never heard of those. If the I wasn't planning on it. Maybe it's somewhere in the book and I just haven't seen it. What? I don't know if I can do this. The way to find derivative functions which are not differentiable. Okay. Uh yeah, I don't know how you would even start a problem like this. Like I could guess that the geodesic is just like a smooth spiral. I have no clue how you'd actually calculate that distance though. The idea is to use integration by parts to find a derivative like a function, which you verify the integration by parts when our function is at the beginning. The result must stay the same when you multiply every function. Uh. Yeah, I don't know if I'm following that storm. Oh my god. I don't want to listen to this song. Well, yeah, I mean, I don't know how the top-down view is going to help, to be honest. There is some, like, the base has radius 1 and that has length 1. So, like, I can imagine the path as something like, I guess it would look like that from the top down. But, like, I don't know how you get that length. What's the answer? I have no clue. Song mixer's been kind of wild. Yeah, I've been trying to play different music on the stream because I'm sick of my usual stuff. I'm not crazy about the music that I've been playing, though. I mean, sure, I kind of rather just not work on the question, to be honest. Oh, yeah, sure, Lucas. Analyze a big math problem? I mean, the only thing you really can do is break it down into parts. That's kind of a hard question to answer, Pav. Hey, Dumoulin. Yeah, Storm, I have no clue how to do that, so I'm gonna move on. Let me see what Lucas posted. I'm doing good, Dumoulin. How about you? Joseph says that no calculus is needed. The typical way to write symbols is with LaTeX sock now. Like, it's like, but just like to get them in normal text chats, I don't know the keyboard. I do have that, I guess, if it's like, so people can copy paste stuff, but that's really annoying to do also. Pav and Lucas, you guys are talking about two different questions, I think. This music also sucks, man. I'm going to this playlist. Sorry, I'm just not feeling it. Grocery store music? Yeah, that's actually kind of a good call. Uh, so this is for the thing that Lucas has been working on, and Lucas, you actually like the place you posted it. I don't mean for that to be posted. You posted like the math resources thing. I might like delete that thread just because I don't want it to be it'd be better for like math discussion, I think. Um, you know. And so Lucas is defining this like a wedge b thing to be the max of ab plus one. How are you doing this here? Yeah, it is a little bit dark. I'm able to read it on my end at least. I don't know what's coming through on the stream. Uh, so if you want to really do this like 100%, uh, it looks like you've worked it out for a wedge b. I would do basically the same work, but for b wedge a. Oop, a. And then you should get the exact same thing right here, and that's like that's how you would fully show that a wedge b is b wedge a. But I mean, you could also just like say in a sentence like repeating this procedure with b wedge a will yield the same results or something. Is probably how a textbook would say it rather than doing the entire thing. Um, but you should talk a little bit more about b wedge a. I would say, because you only talk about it at the very end. You don't say what it actually is. So that's the only thing I'd add here. Okay. Yeah, cone one, no clue. Just gonna shove it somewhere else. What's one and one? I don't know if you're talking about the thing we were looking at just before pub or not. I didn't catch what you meant by that. Joseph, I that's not helpful for me. I've thought about that. I don't know what it does. The thing I just wanted to investigate was, oh, Geodesic is a straight line? Was I just imagining? I guess I was imagining the geodesic wrong. I don't know how you figure out the actual shape of the sector. But if it's like, I guess like convex, that makes sense. You'll be going from here to here? If it's concave, I don't know how that works. Like if you have a sector that looks like Pac-Man. So that like when you're saying done for a cone, I was imagining something more like this, and I think you still get a curve here, or it seems like you have to. So that's why I didn't know what to do. I guess maybe this particular cone looks more like this though. Oh hey, there's a mind explode emoji. The slant height and the base radius. Geodesic lines once around the apex wouldn't exist? I don't see why not. Oh my god, that's such a long emote name. But in Twitch, you can literally just type like colon. Like I'm hovering over it to see the name of the emoji. Shocked underscore face underscore with underscore exploding head. If you literally type that into Twitch chat, I think it. Oh, you can start to type it and it'll come up. And you just like hit tab. There you go. But just literally type colon shocked and then it'll start to like, it'll come up. If it's concave, it's super flat cone, you can imagine that it's limiting towards a flat disk. I don't see why that. No, I still don't see why that geodesic couldn't exist. The other issue with this idea is I don't know how we get M and N. Like N is probably going to like go through some point here and then double up and follow the same path. No, it won't. Will it? I think it'll follow the. Maybe it's just twice the length of. No, it's not twice the length. Shocked by how long that emoji name is. So I still don't know how to actually like solve it. I don't feel like because M and N are still a big issue, but theoretically I could maybe work out how to get L at least. It seems like a lot of work though. This wouldn't be curved enough for the geodesic to curve enough to reach the top point. I really don't see what you're saying, Joseph. I'm sorry. Like, I feel like I can pretty clearly just, like, even if it was a really flat cone. Like, I can always draw a spiral like that. So I don't get it. It's an eighth of a circle when we cut and unroll it and lay it flat. Maybe. I don't know. Joseph's saying yes. Oh, you know, I'm going the wrong direction with this implication. I think we want to... We want to start with this. Okay, that's where they're getting this relation from. This thing is magnitude 1, so it goes away. Okay, now I understand how this thing follows directly as the book said. Uh, it is the L1 norm of F, which is a measure theory thing that I haven't learned before, but you can take this piece here as just the definition. Integrate the absolute value from minus infinity to infinity. And oh my god. I've been reading this complex analysis book, and I'm just getting into Fourier and Laplace transforms. And they're talking about these L1 and L2 spaces as being relevant to Fourier transforms. This is the L2 norm. And I think it continues in this pattern for higher numbers. And so they're saying it has to be finite in order to be included in L2, which is a space of functions, which I don't know how that's different from a set. I assume it is different in some way. It's kind of weird because, like, this exponent of 1/2, well, it could affect the convergence, I guess. But wait, the 1/2 is all on the outside. Oh yeah, p can be a real number, not just integers, right? Like, does 1/2 ever affect the convergence? You have to do the limit first and then square root it. So, like, isn't this 1/2? Maybe it means it still affects the actual value of the norm, but it doesn't affect the convergence. Oh yeah, sure. Oop. Oh, okay, I did. have the property of multiplicity of the norm. I just have to believe you on that then. Okay, but I guess that it makes sense here that it's not needed for, or it doesn't affect the convergence, but it's needed for another reason, I guess. Yeah, Lucas, this looks good to me now. And so a lot of times if you're reading a textbook, they'll just say like, you know, and repeat the process with B wedge A and not write the entire thing out. But this is like the proper way where you're showing every last thing. If you were to try to like write a paper on this or something, you probably would want to just like cut that part out and just like say repeat the process with B wedge A. But this is what is actually going on in the background as you do that. So I'd say like this is like the more complete version of that proof. Yeah. Yippee, indeed. Okay, so that was one thing from the book that I was a little bit confused on. I've worked that out. Skirtle, self-knowledge is a lifelong process. Hey, that's an actual fortune there, unlike yesterday. The yippee sound effect? No. Who says, is it like Mario who says that? I can imagine like a really high-pitched yippee. This life is yours. Some of it was given to you. The rest you made yourself. Ooh, that is a good one. Yeah. Whoever's making the fortunes got their shit together. A young German girl? Oh, I haven't heard that one then. You don't have to draw M and N on the unrolled cone. Yeah, that's my issue too, Fembox. Just Vinaigrette saying add 2 more copies of the unwrapped cone next to the initial cone. Now you have 3/8 of a circle? I don't see that at all. If you're curious to like have your own like copy of it to look at, Joseph did post this question in the Discord along with a spoilered answer that I won't show. But it's here in math discussion. This might be loud. Let me turn down the audio preemptively. Fortnite? Oh my god. I can't listen to that. That's a little too annoying. I think I don't want that sound effect. Oh, yeah, sorry, Joseph. I don't send the audio to YouTube because of copyright issues. That's the link there if you want to watch it for yourself, though. Oh, you're over here. Nice, Skirtle. Did that heuristic that I didn't feel was right. Oh, it does work. And if I'm wrong, the geodesic that loops 3 times actually gets closer to the vertex than point C? Really? Oh, okay, I can kind of imagine that does make sense now that I picture it. The closer you are to the vertex, like the quicker you can do a circle around the cone, right? The radius is smaller. So I can see that there could be an advantage to going above C, yeah. Sure, guys, to interview Math Life Bounce YT channel. It was awesome. Really? Can you drop a link? I didn't realize he was a big deal. But one of the schools I applied to, I think, was Cornell or whatever school he's a faculty at. And his faculty profile stood out among every other faculty profile I looked at when I was like pretty much for every like person who I've looked at, regardless of the university. And I was like, that's the guy who I like would be excited to like work with. It makes sense now why I got like rejected from there, because A, it's a really good school in general, but B, because like you probably need to be really smart to be a grad student for Strogats. He's near Go and dynamical systems, yeah. So I'm definitely interested to hear this interview. Not right now, but after the stream. Yeah, Cornell. So not knowing who he is, I said that's the guy who I want to like work with. He like I maybe he said it was like passionate about like math communication and going on like podcasts and stuff to talk about math. It's like, oh, that's really awesome. And he likes dynamical systems and stuff like that. Joseph, yeah, he's on the Discord. The same name. What else was I? Okay, you know what? Let's work out 4.5.1. My junior advisor also works there. Ina Zakarevich. Let's see. I'm curious. I'm gonna pull a Stuki and just Google mathematician. I don't know why I hid the screen for this. Algebraic topology. Theory of scissors congruence as K-theory. That's a new one. Scissors congruence? Is there like, doesn't feel like the real page. This feels like the real page. Huh. Combinatorial aspects, not geometric. View of topology. Algebraic topology. The Annihilator of the Lefschetz motive? That sounds like the name of a movie. Read Prof Z Guide PDF. Uh, Where is that? Was it on this page? Oh, okay. Guide to doing homework effectively. Turn off your phone. That's going to be a hard one for students. This is really prescriptive. Really? I mean, online, yeah, don't look online too soon. But in the textbook where they don't solve the exact problem, I'm kind of surprised. Hmm. That's kind of interesting that she wrote that. Flexagons. That's just fun to say. Hmm. I'm always winning at Roblox. Color cone. Okay. Vihert thing? I don't know who that is. So I think we're finding the Fourier transform of this function. Yeah. Let's just go through and do that for ourselves. No, definitely not color code. Desson said that that was his dream advisor, and so I was just curious to look her up and see what type of math she did. It was a Martin Gardner thing way before it was a Weihart thing. No, I've never heard of Weihart. Also, why do we need capital F and a hat? Like, just being capital F is different enough. Why do we also need a hat? Gardner sounds familiar. No, I don't remember anything in particular, though. It's an operator, presumably? Oh, maybe. because it's Ep's birthday. He just turned 18. That's the party hat. You know, Martin Gardner, I'll have to politely but firmly ask you to leave. My own stream? Damn, I just have like get up and leave. Martin Gardner. Donuts? Magic, scientific skepticism, micromagic, philosophy, religion, and literature. It was your 18th birthday yesterday, so you'd have a hat on yesterday. Well, happy birthday. Martin Gardner sounds like a restaurant. Like Olive Garden? When you're here, you're family. Who was Lewis Carroll? Oh, Alice in Wonderland. He sounds like a steakhouse. I could see that. Ooh, lived to 95. Born in Oklahoma, died in Oklahoma? Damn. It's scientific skepticism. Okay, that's what that means. I feel like that term could go like either doubting science or doubting unscientific things. So I wasn't sure what they meant by that. This is doubting things that aren't scientific, which seems all right with me. Mathematical games columns. Oh. Holy crap, his eyebrows. Oh, he fought in World War II? Holy crap. Hexaflexagons? Yeah, the mathematical games. That's definitely what I would guess that you would like about him. Watching YouTuber do Euclidean geometry the other day. We tried on geometry. Everyone notices when you first learn Euclidean geometry that when you move around the lines or make bigger such amount of geometric figures, sometimes the properties are lost, sometimes they don't. So if these deformations can be studied using geometric figures as points in some space that change continuously while holding its geometric properties. That almost sounds like conformal mapping type of thing with like topology or something. I'm just kind of saying some buzzwords, but that sounds like something that mathematicians would study. He had problems learning calculus and never took a mathematics course after high school. Wow. Inscribed circles in a quadrilateral, we can use pivot, or I assume that's supposed to be pivot, to continuously deform it until it cannot have an inscribed circle. Okay, yeah, I assume you're like changing angles or stuff like that. Oh, Pitat's theorem? Pitot? It's probably Pitot or something. Oh, yep, French. Okay, it's Pitot. Pitot. Uh, isn't pito? I think it means penis in Spanish. Just Pitto. So that's kind of close. In a tangential quadrilateral, the two pairs of opposite sides have the same total length. It's kind of random. Why would that be true? If I'm going to ask why, this is why down here. I don't really want to learn why, though, to be honest. Hey, One Side Gamer. It's a weird French name even for a native speaker, really? You found something very, very peculiar about my new wedge thing. It's commutative, but not associative. Right, I remember we talked about that. Yeah. Cool. Something called a pitot tube for measuring air pressure. They mount in the wings of airplanes. That did come up when I was putting in pitot. Pitot tube. Oh, NASA has a page on them. My brain is turning off looking at this picture. Okay, I don't I don't want to read this. It's cool that that exists though. Proof in the gray pick. Oh, I already clicked off. I'm just quickly figuring everything out. I don't care if everything's 100% correct, just 90% correct is good enough for me. Hell yeah. 90% good enough. Lucas has been talking about his own wedge type of thing. It's not like it's like a Lucas original algebra. I don't know multiplier maps or multilinear maps. No, I don't. It's not. I haven't learned what wedge products normally are in math, but it's not that. Yeah, $10. Well, as far as I know, it's new, but it's hard to verify. Yeah. It isn't. I learned stuff from it. Yeah, that's the most important part. When do I create my own topic in math? Probably never. That's just not really what I do, to be honest. The wedge product somehow magically computes the volume of a parallel pipette. I think that is the general kind of version of a wedge product. Lucas is making up his own wedge thing, but I feel like the wedge product does have some. Oh yeah, because the cross product can be used to compute the volume of a parallel pipette, right? And the wedge product is somehow related to the cross product or something. Just kind of change my definition of A wedge B, which kind of comes from Zach. Okay. So for computing determinants? Oh, okay. What's happening with this in the limit? As x goes to infinity, it's just going to 0, right? We don't need to worry about having a complex number in there. Yeah, I think it's just going to 0. When x equals 0, that just becomes 1. So we get a positive 1 over a plus ik after the dust settles. With this, we get a... just get that. Not sure, but it can even handle smooth, compact manifolds. Fair enough. This is not associative. Keep that definition. Yeah, it's okay to not be associative. It can still be interesting or helpful in some way. Yeah, Felix, I can find the course description. University of Washington. Somewhere in here. So that right there. Also on that same YouTube channel, Grant Sanderson was interviewed. That's awesome. Quiz question. People called a commutative ring a ring where multiplication is commutative. Do you think a graded commutative ring is a commutative ring? Well, I'm gonna guess no. Although it really should be from the name. No, it's all 500 or more for the higher level classes. It's not commutative. So it receives an F on its commutative grade, is what you're saying. It's a graded commutative. Also, my schedule is going to suck. There's literally, I have 3 classes, all Monday, Wednesday, Friday. This one is just Monday, Wednesday. And there's like 3-hour gaps between all of them. And I hate having, like, a 1-hour gap is okay, but 2 3-hour gaps is ridiculous. It's like 1 morning, 1 afternoon, and 1 evening. And that's just like the worst schedule you could have, I feel like. But yeah, no, I'm excited for this. Excellent library time. They do have a really cool library. Can I find it? Let me see. Let's see. I forget what it was named. Like, yeah, this is the, like, they called it like the Hogwarts reading room or the Harry Potter reading room. I've been inside of this. I guess it's just called the reading room. But yeah, it's like a silent study area, so like you can't talk when you're inside there. But it like, this just looks amazing. The exterior algebra wedge product stuff has a great commutative ring, but not commutative. Okay. To show you one of my schedules I have from grad studies, 3 classes in 1 day on Tuesdays. Oh, well, that's gonna be all of my Mondays and Wednesdays, and then Fridays will just be 2 classes. Excellent time for a sneaky library Twitch stream. That sounds, oh my god, I'm gonna piss off everyone in the room if I do that. Schedule is awesome right now with 3 classes, same classroom from 8 to 12. Ooh, that is convenient. Like, yeah, it's graded commutative, not graded commutative. I like that phrasing, Joseph. They have a hat to sort students? Unfortunately not. I think it would be creepy in real life, though. The sorting hat? It looks kind of messed up. Like, just imagine having to put that thing actually on your head. Like, yeah, I don't know. How to draw the sorting hat? It's really specific. Husky door or barking claw? I have done the Harry Potter house quiz, and I got Hufflepuff, I'm ashamed to say. And the only thing I know about Hufflepuff is they have the lamest name you could possibly have. I mean, if there is a UW edition one, I'll do it. I doubt that exists. Drawing stream? Probably never. I mean, honestly, I take that back. I would like to do a Bob Ross like painting stream one day, but drawing I'm terrible at. People on Twitch, there's a can make me draw things. It's like a channel point redeem, but I would never do like a dedicated drawing stream. Is this everything that I guess I found the Fourier transform. Oh, speaking of, Bob Ross painting a painting. Okay. I've been watching Bob Ross again too. The last like week or so. You never went to the main library. The main campus is filled with social people. That sounds terrible. I don't blame you. You badly drew Clippy? Oh, really? I really honestly really like the idea of you having an E-shaped Clippy as your like mascot. Oh wait, I just realized that you. Oh no, is he painting a Kappa emo? Okay, I'm taking that as a yes. To be fair, I could just take a screenshot and copy paste a Kappa in, but that's against the spirit of the draw it. We'll get a happy little Kappa in there. He needs to be, his legs need to be a little longer. I think I could have made a living as an artist. Can you actually draw, or are you like making a joke? I feel like I never heard you talk about drawing. He's smiling because he's Bob Ross. Do I have a brown color? Uh, Custom color. Here's brown. Yeah, this is Bob Ross. Why is that there? Okay, so in his left hand, he has the circly thing that artists have, right? So, and he has a massive one too. That's what she said. Uh, if his probably isn't the first time that I've drawn Bob Ross either. That's me. Oh, hey. Okay, yeah, fair. Oh wait, you're making a joke at because that's an okay, yeah. Maybe I'm gonna have his arm out to that side, and he'll be holding a paintbrush. I could not resist. You're right. Others are encrypted. I probably don't have that in Journal Plus Plus. And also, Kappa is just in black and white. So, if anything, this is gonna be like that one episode where someone told him that they can't follow along with his paintings because they can't see color, and so Bob Ross did an episode of only using like grayscale. Actually, he might have done a couple episodes, but he's definitely done at least one where he only uses like one color. I don't know how to. I'll represent the white with light gray, I guess, like the titanium flat. It's kind of a titanium color, I guess. Now I have to draw a Kappa. My first and only painting, actually the second? Sure. I'm starting with the ear for Kappa, and I don't know why. Just feels right. Saw painting of yours on Phobos stream one day, I think. It was awesome. Oh, really? This is like real? Oh, well. Wait. This looks like a... Is it okay if I show it? It looks like you painted over a photo, or like, is that like just part of a painting? I guess it's all a painting. If you made all this, that's really impressive. Any trips? I don't have any trips aside for moving. You leave in 2 weeks? If you say in 2 weeks forever, never come back. Are you actually about to take a trip? Oh, it's awesome. Where are you going? That's why you sent it? Okay, so I could show it. Okay, so I was confused because like this part down here looks so like different, but I think it is all the same painting. I assume this is all like Descent, in which case that's really like awesome. Didn't do it over a photo. They just watched some Russian painter on YouTube. Oh, okay, nice. Taking my Dell Latitude laptop so I can continue my programming grades. I want to finish my associate's degree before 2026. Do need to finish paying for the paper though. Fair enough, fair enough. No rest for the wicked. Yeah, that's like amazing. Well done. Someday you will. It's really hard to do people, especially. Wait, I need another kappa in chat so I have my reference material. His face is really... There's not a lot of detail in that face. That nose is not even close. Oh, the Kappa Ross. I could make him a Kappa Ross. Is that an original Don's piece? Yep, this is all me here. Ooh. I guess that's my Kappa. Oh, Mob Justice. I forgot I made that. I I think I made it. Okay, if you vote me, I think it just won't work. Um if there's a tie though, yeah, they both get timed out. It's only for 30 seconds, so it's like a harmless thing. Kappa Dawn? I don't know. For Kappa Dawn, I would just like add glasses. Yeah, see, they're already back. I know, I saw that one might be like kind of funny. Next time someone says like pineapple on pizza, everyone can like vote to time them out or something. Which honestly, I actually do like pineapple on pizza. I should have made this bigger. Can I just scale it up? Can I be lazy? There we go. I could make a Kappa face. It's just a straight face though. Like a nice like Hawaiian pizza. Yeah, I actually do like that. Mob done. So I don't know, Zach. It's just good with you. I can make this a Kappa Ross. Is there only one place where it's only one place where it's acceptable, but any other place not ain't good. Wait, where's the one place? Kappa Ross is acceptable? All right. Kappa Ross, that's an easy conversion. Gonna need more room for the hair though. Just chop off the top there. Oh, pizza buffet place. Okay, like a local place. I was expecting like it to be a chain or something. Oh man, this looks like a cartoon character. I can't remember which one though. I don't remember. It needs to be bushier. That's the problem. Bushy. Make it a little bigger. Zoom and enhance. Wait, do you not know who Bob Ross is? Color code? He's a painter. Like going to, oh yeah, I read that. They charge like $12 for entry. Ooh, that's not bad. My food research near campus? Not near campus, no. I have looked up restaurants. So I went to visit back in April. And in preparation for that visit, let me count them. I found 67 cafes. Unfortunately, almost none of them are actually by the school. And I found 37 restaurants. This is 67 cafes. It is a little bit inflated by places that have multiple locations. They do have a really good burger chain called Dick's Drive-In. It reminds me a lot of In-N-Out. Honestly, it might be better because In-N-Out is just okay. But it's really cheap, it's really quick, and it's not bad at all. I wanted to go to a place called Un Bien, which is like a Cuban place that's supposed to be really good, but it wasn't in the cards. Wait, was it Un Bien? There's a place that they had like Cuban sandwiches or something. That was supposed to be good. Oh, on the canvas. No, just like the Kappa emote. And then we turned it into Kappa Ross. I don't know who he is, if that's what you're asking. I don't know where the Kappa emote comes from. None of them are Starbucks. I don't. I'm not above going to Starbucks, but I don't particularly like want to. I would go if I have to, but you went to do some stuff that's actually turned into a drawing stream. Yeah, right after you said that Joseph, Zach, or Ethu did the redeem to make me draw this. Big cup of iced coffee. Ooh, nice. Is that still in the US? Starbucks? Yeah, there's one on every corner. When did the drawings start? I never keep track of time. Probably like 10 minutes ago, if not more. Actually, wait. 17 minutes ago. Oh, that's a smirk? I guess I can see it now that I'm zoomed in on it. Josh DeSeno, I'm gonna play at Justin.tv. Oh, so it's a Justin, or it's a Twitch employee, basically. Derived from the Japanese mythological creature called a kappa. Oh. Huh. Now you know. Um, no, I'm a coffee snob. I enjoy light roasted coffee because I just think it's better for my preferences. And Starbucks roast very dark. Um, oh, wait, does YouTube have a kappa emoji? It does. What is that supposed to... It's hard to tell when it's so small. I didn't know it was a smirk. It's too small for me to see it. I know I meant sarcasm. I didn't realize that it was like smirking. Edo period talking about kappa. That's the monster. I don't know what that emoji is. Okay, we're calling this a drawing. I'll post it in the Discord. Hey Loki. Because I think we've allegedly found the Fourier transform. How does this function look? It looks like a weird parabola, right? With like a corner, maybe. When x is positive, maybe it's not. Maybe it's more like a Gaussian distribution. Wait, okay. E to a negative power looks like this. But we cut it off so it's only the positives. Okay. So it's almost like a Gaussian distribution that has a corner on top, not a smooth. And they might be scaled differently also. And so let's also reverse this. Flip our thing back, put it down, and reverse it. You proved commutativity. Shown with examples is not associated except for some patterns. You've showed there is no element such that a wedge x equals a. That is a good question. Now what? So like you started thinking about this to try to do something with logarithms, right? You could try to define like the logarithm of a wedge something. Or like try to involve like functions of any kind now. Like what happens if you square it? Or something. That could be a natural next step, but oh yeah, I guess like you could even just like try to solve a more basic equation first. Like that's fair. Yeah. I guess you would need to work on stuff like that first. You're right. And so if you do want to involve other operations, like it'd be good to make a hierarchy for like the order of operations. So like, you know, we usually have like PEMDAS, at least in English. I mean, maybe you were taught it different. But like, you know, you do parentheses first, and then exponents, and then multiplication, division, and then addition and subtraction. It'd be good to like slot in your wedge somewhere in here. Papadoria, Lucas has invented his own like algebra. I guess basically like a wedge b we're saying is max of ab plus 1. And Lucas is just like exploring like what you could do with an operator that's like that. Sure, I guess he doesn't like to spoon feed his grad students. They come up with their own work. He'd still be down to work with him. Yeah, I mean, I remember reading on his page that he kind of lets grad students determine their own path a lot. Which appealed to me because I don't have a particular path that I'm really set on. So, yeah. Seen some grad students in my school who had professors that were not faculty. That sounds uncommon, right? Oh, I mean, that kind of works too, Lucas. I think that gets across the same thing. But if you have like 2 times 3, so, well, I guess like plus 1 squared, like there's a certain order that we do this stuff in. Like we would always do the stuff inside first to get 4 there. And then we would do the exponent. And then we would do the multiplication. So like I just mean like, where would the wedge be involved there? But you don't have to allow multiplication or exponentiation if you don't want. Yet an emeritus faculty member of my committee, that's more of an exception than a rule. I mean, for a committee, that seems an easier sell. Does the commit, well, does the committee only evaluate you at the very end, or does the committee also like guide you through it? I forget. So I know you definitely have like one like I guess like principal faculty member that like really guides you through it. I don't remember if the committee in general also guides you through it, or maybe like they're there for the major milestones, like they say whether your idea is good or not before you pursue it. They help you through ideally, but I feel like I only got evaluated once a year. Okay. So this may be like what it's mentioned, where they're just there for the major milestones. Prepimnos is the annoying rule, which is the most annoying or disgusting to get rid of first. I mean, that depends on your opinion, I guess, whether you're gonna get the right answer or not. What if I really find addition annoying, so I do that first? But there's some parentheses in the way and I just ignore them. I had explored the use cases and geometric meanings of the AND operator. Ooh. Oh wait, so I was thinking of like bitwise AND, like computer science. But you're just doing something else there. That's interesting. So you said that A, how do you draw this? And B is equal to A squared plus B squared over A plus B. So yeah, I have no clue what like properties I might have, but that's like, that could be an interesting one too. Okay, so I think I want to take this thing that I found and run it back through the inverse. Proved a useful case of the freshman stream geometry. Oh, nice. Clean hyperbolic spherical. Cool, cool. Imagination can go wild for operators, but actions are something else. By actions there, is that like the functional analysis idea of action? That's where my mind is going, at least. This is kind of... So our original function has this domain, like, it's like piecewise. The thing I got out of the Fourier transform, I guess there's... K is a real number, I assume. I guess there's no discontinuities. But it's also, like... It's not piecewise. Let's just blindly apply the reverse transform, or the inverse, and see what we get. That's annoying to integrate. Uh... Knowing Fourier series brings up any function to sines and cosines. What is required for functions to be summed up and mimic any other function? That's a hell of a question. Wedge comes with 4 plus? Okay. Hey, syntax, this is, I'm messing around with Fourier transforms, and for the reason the book I'm using uses, once you apply a Fourier transform, the book uses the variable k. I don't know why. I think S is the one that I usually see. That's a good question, probably. Like, why couldn't we use like an infinite sum of logarithms to represent a function? And I don't know. Yeah, I mean, I was really just working through an example problem from the book. It was to find the Fourier transform of that right there, which I did. And then I was just trying to reverse it. But the integral you get to reverse it is kind of annoying, so it's going to take some thinking. But yeah, I'll leave that there if you want to like take a note of it. I'm trying to think of something good to like Google. Just want to see the current step. That right there, basically. Taylor expand? That's an idea. T lot for Fourier transform? That makes sense. Can you make transformations like a Fourier transform, but with other types of functions? It's on like Donkey Kong. DK. Donkey Kong. Use any functions you want to generate all kinds of crazy spaces. So then just one particularly useful because they are orthogonal. And you can filter one frequency out without affecting all the others. How did they create PEMDAS? I don't know if there's a reason PEMDAS has to be the way that it is. I don't know if you can find PEMDAS from something else. I think it's just the order that seems to be the most interesting version, I think. That's a good question, but I think like PEMDAS just I'm struggling to think of a good answer. I think they kind of probably tried a lot of orders and just kind of settled on that one. For probability question, there's a few ways we can think about Fourier series. There's an analysis way to think about that using self-adjoint operator. Some more algebraic avenue using representation theory. Interesting approach, take with respect to A and B. Partial. Then wedge comes utter last. Maybe, yeah. Where this was the last step in diffie Q. It's very computational. No limiting geometric idea at the time until I watched this YouTube video. Then I said, okay, this is important. Categorification of Fourier theory? I don't know if I don't know about that one. Too much drink to spell. Take the derivative with respect to x? I don't know what that's gonna do. Categorification is one helpful word, it is. So what I care about Fourier series is that they form a basis of eigenfunctions for the Laplacian over the unit circle. Pretty much like denationalization of matrices? Diagonalization. I was like, okay, denationalization sounds like something else. Sounds like you're getting kicked out. Yeah, I mean, it's kind of an interesting thing, Poppatory, that like, surely the Fourier series isn't the only interesting transform. But I don't know of another one that's like, will be considered interesting. Oh yeah, we've talked about the melon transform. I don't remember what it looks like. Algebros, I'm sorry, I don't know how to do that question. Sheafification? Oh my god. Fourier Mukai transform. This one, I remember looking at this. I don't remember we thought about it. Fourier Mukai transform. Is a functor between derived categories of coherent sheaves for schemes X and Y, which is, in a sense, an integral transform along a kernel object. Okay. Yep. These are words in the English language. A sum of Gaussian distributions works. That's an interesting idea. Algebra has also been showing for a little while longer, but I don't know how to do your question. Probably the worst introduction ever. If you could make this understandable, I will be really impressed. This is some pretty high level math. Sounds more like computer science now. That's category theory for you. Oh my god, a superscript on an operator? That shouldn't be allowed. Hey, nobody's here. I'm doing well. How about you? Derived tensor product. It's good to hear. Is dy the category of a D modules? I don't know why I'm trying to answer that question. I don't know. I don't think that's exponentiation. I think that's a specific type of operator. I think it's an operator that... Yeah. Ugh. We're now looking at intergalactic symbols. We sure are. Challenge to make it understandable, impossible. So yeah, Papador, I don't know. And we can keep on looking around on Google. Algebras, I don't know where those problems are coming from, but those look like challenge problems that I don't know how to begin to solve. I like those look like competition problems, and I don't know how to do those. The Fourier-Mukai transform is like a Fourier transform for geometry. It takes geometric objects on one space and systematically re-encodes them as geometric objects on another using a fixed kernel. Okay, that's more understandable. Interesting puzzle? Yeah, sure, Zach. Okay, see algebras. Functions out of their own Fourier transform. Oh, that looks like a Gaussian function. Gaussian distribution. Arbitrary circle with an unknown diameter. Okay. A sigh. Ugh. One over Kosh. It's its own Fourier transform. Hmm. Okay, ugh. Let's start. Bringing in Zach's problem. Commie algebra? A damn commie algebra. Okay, arbitrary circle with unknown diameter. 30, 60, 90 triangles inscribed on one side, and a 45, 45, 90 triangles inscribed on the other. The diameter is a shared side. What percent of the area of the circle is the sum of the two triangles area? The diameter is the hypotenuse on both right triangles. Okay, okay. Hypotenuse of both. I was how is that going to be possible? I thought they would have to not have their hypotenuse. Oh wait, okay, no, maybe this is possible. This actually, I feel like this is going to boil down to something pretty simple, but getting there won't be easy. Benbox is already done. So it must look like this, right? Because if you change the definition of A wedge B, that's max AB plus 1. So A wedge B plus C is max AB plus C plus 1. Okay. PEMDAS wedge, there you go. What percent of the area of the circle is the sum of the two triangles area? Compare heights and done since they share the base. Oh. Hey, Gianluca. You find hard the qualitative study of ODE? So like proofs involving differential equations is how I'm interpreting that? There's just some noise outside. I haven't studied that deeply for myself, to be honest. ODEs can have some kind of weird proofs. Yeah, I don't have specific advice aside from just like reading through proofs, like, you know, read through a proof once, try to understand it, and then give yourself like a day or two to digest it, and then come back to it and see if you understand it better. But like a whole type of stuff, you just have to kind of keep grinding at it. Name it split so it's PEMDAS. That'd be funny. My professor was playing a trick on me because he asked me to study over the summer. I'm running with the pace extremely slow since I'm mainly studying for algebra. So it would make sense. Like, we should just need these two heights here, and that's going to be the hard part of the problem done, I think. So for the 45-degree triangle, should I get example and counterexamples to fundamental theorem of distance and uniqueness? Good idea to study the flow for linear systems. Okay, nice. So I'll solve log of a plus b with what I'm doing. Oh, yeah, you are causing yourself an issue there. Oh, Joseph, true. That's just the radius. Yeah, great point. So we only need to get that for the 30, 60, 90. Now how do we do that? We know this entire length is 2r. I guess we can use trig to get like this side here. 2r sine 30 or cosine 60, depending on your preference. And so that means that height there will be 2r sine 30 sine 60, right? Let's simplify that. Sine 30, 2r sine 30 sine 60. Root 3 over 4? Wait, oh, yeah, then the 2 is canceling. Okay. Okay, so we get 1/2 base 2r height root 3 over 2r plus 1/2 base 2r height r divided by pi r squared. And whatever that is will be the answer. Root 3 over 2 plus 1 over nothing. Over pi. Okay. Fenvox is a speed demon. New math is always good to discover. I think math should be like this, but unfortunately math is hard and some people need to make a living off of math by publishing what they have. True. But because a ton of people don't know, make the quiz result in math, they decide wanting money instead of actual new things. Yeah. Nice problem, Zach. Joseph, I'm not going to stream for much longer. If you want, I can send your question, but if it looks too hard, I'm just not gonna do it. You know, 3069 triangle is better than I know my mother? Dang. Derivatives of log? Uh, That's just kind of like a formula, to be honest. Like, or wait, do you mean logarithmic differentiation? Because the derivative, okay, we're like, you mean if you have like y equals x plus 1 squared over x minus 2, you would take the log of each side to simplify it and then do the derivatives. Like that's what you want to hear about? Okay, so I'm going to do that first, and then I'll take a look at Joseph's question. So yeah, this one, you could do it with quotient rule, but we don't like the quotient rule here. So we can take the log of each side, and I'm going to do the natural log. And then the log is nice because we can use log properties to simplify that. Log, rah. So first, when you have division inside a log, you can make that subtraction. And then this exponent can come outside. And so that's as many log properties as we can use. So we're ready to take the derivative now. So let's take the derivative of each side here. So taking the derivative of the left side, this is implicit differentiation, remember. So we start by pretending y is just a normal variable. So the derivative of ln is 1 over that thing, so 1 over y. But we just took the derivative of something involving y, so we multiply by dy by dx. So that's the left-hand side. The right-hand side is normal. For logarithm, you get 1 over whatever's inside, so we get 2 times 1 over x plus 1 minus 1 over x minus 2. All we have to do here is solve for dy by dx. There is a trick here where this y looks a little bit weird. But, let's start by multiplying it to the other side, and then I'll tell you how to deal with it. If you don't already see the trick. Remember way back when, y is equal to this, so just plug that in. So x plus 1 squared over x minus 2. And that's basically your answer there. If you want, you could like multiply this in and try to group things up, but it's not strictly necessary. Oh. Oh yeah, thank you for that catch. That's very right. Yeah. No worries. Hope that helps. Then Joseph posted this. Derivative x to the x, true. I mean, for that, you just do the e to the ln x trick, right? Larger is fun just to know this rule. Oh yeah, that like format. The complex analysis book was talking about like noticing f prime over f out in the wild and realizing that that's a derivative of a log. I thought it was kind of like a funny trick. Okay, so f is a function, maps positive integers for all a and b. F of a is greater than a. If a is greater than b, f of a is greater than f of b. f of a is 3a. What is f of 99? I guess I'm the messenger here. That's the picture that Destin sent. Oh, using a 30, 60, 90 triangle to analyze a 75, 15 triangle? Huh. So what's happening here? I was only following the conversation. Oh yeah, I see. Mir Shawan, I am okay. I don't want to do that integral. This question, I don't know how you do this. I'm thinking about it. I never know how to do this type of question, to be honest. Yeah, I don't know. You would probably have to find some clever values of a to plug in here, but I don't know. I don't know how you like usually do these. The integral square root of tangent is really long. I've seen videos on it. It's not a quick integral. And I imagine square root of cotangent is about the same. Oh, you have to do contour integrals to get the inverse. That makes sense. That'd be worth actually doing. I guess that's how you get the different domains, maybe? From 0 to pi over 2? Really? Dude, if you just drop that problem and immediately left, that's kind of funny. Like, it's kind of a dick move, but it's also kind of funny. To live up to expectation that you know integrals. I don't. Integrals get kind of tedious. I believe Pohl, who likes hardcore computationally math like analysis and geometric things like algebra. Unbiased. Hey, look at welcome in. Should we do these actual contour integrals? You can feel my brain slowing down. So, where's our discontinuity in the complex plane? It's at minus IA or IB? Minus IB? Wait, no, it's at plus IA or minus IB. India now completely dominates chess. Respect. I mean, Magnus Carlsen still exists, but they're on the come up. You're quite good at math. Oh, nice. Wait, why is the upper half K plane? Why does that mean X is greater than 0? How do you justify that? Math will take care of that. Math is pretty good at humbling people. Well, it should be. 99 in math in 10th board exams. Nice. That's awesome. Hmm. Okay, you know what? I don't think I want to do. I don't know if I have a contour integral in me right now. I probably should just end the stream soon here. They do talk about the Dirac delta function here, which is cool though. There's 250 tons of gold. Howda? Huda? I did not know that. No. It's a lot of gold, it sounds like. Okay, you know, I think it is time for me to call it. I can feel my brain crapping out on me, so call it Embari. It's for God. Oh, that's cool. But yeah, I think that's gonna be it for me for the day. I plan to be back on Tuesday. Uh, I'll search for it later. But yeah, so this next week of streaming is gonna be my last week before I move, and it won't be a full week either. I'm glad you enjoy them at $10. You almost cracked the second one? Oh, nice. For my Suru? Nice, Looketh. But yeah, so I should be back on Tuesday. As far as I know, I'll be streaming Tuesday, Wednesday, and Friday. Thursday, probably. But definitely not on Saturday. So, sorry, Looketh, I gotta go. So yeah, YouTube stream is gonna end here. On Twitch, we'll look for a raid. Yeah, Joseph, thank you for hanging out. Sorry, I don't know how to do your problems, but thank you for sharing them anyway. Sorry, MG. So yeah, everyone's here on YouTube. I'll see you later.